Hello guys, hope you're doing fine. And as always, if you are new to my channel, I would humbly request you to subscribe to my channel so that you would be able to watch all my newly uploaded engineering videos which shall be beneficial for you in your current and future studies. Thanks. Alright, so the problem at hand is that we have a worker who's walking up the sloped roof that is defined by the mathematical function y is equals to 5e to the power 0.01x feet, where the x is considered to be taken in feet. You need to determine how high h, which means this, how high h he can go without slipping. Okay, so the coefficient of static friction is given as mu s equals to 0.6, and he is terming to us that how high along the y-axis he will go without slipping. So in order to solve this problem, we must have to look into account that basically what type of regime of motion for friction is basically being considered in this problem. Okay, so it looks as that he is only considering the process of friction in which slipping is not required. Okay, so for this, if we go, so we can say that if we look at this curve, a very important curve over here is that this curve, if you look at it. Okay, so this curve tells us that there are three types of friction cases. This is if the value of the applied uh, force P, and this is the frictional force F and Fs and Fk. If this value, the applied force P, is lying within this zone, okay, is lying within this zone, so there will be no motion in the body. Okay, so the scenarios considered in this zone will be no slippage and no tipping. If it reaches this point, this point over here, if it reaches this top point, which is the point of Fs over here, then the impending motion will be considered. And if we cross this point and we go into this zone, which means that now you need to replace mu s with mu k, and the body has started its motion. Okay, so but in this scenario of our problem was, we are basically in this zone, and we will only be considering the slipping scenario. Okay, so just a brief reminder, when you are studying dry friction, you will be able to always use this curve, will always be guiding you, whether you taking the scenario of considering no motion, impending motion, or the motion has already started. So with this knowledge in our mind, now when we go to see this numerical, we see that the this is our x-axis, this is y-axis, and this person is standing over here at height h. Okay, so what we will do, we have to change, because this is a sloped roof. Okay, so we will basically cannot use direct our x-axis and y-axis as standard. This is our x-axis and y-axis, so we will be just shifting it along the sloped roof, and we say that this is our x-axis and this is our y-axis. Now if you look at it, this person weight will be always taking as vertically downwards. The weight will always be taken as vertically downwards, and the friction force as the person is going up will always be acting behind him. Okay, because if the friction force is not acting behind him, he will start to, this person will basically lose all the momentum, and he will start to go down from where he started. So the frictional force is basically this is the direction of the friction force, which is stopping him from slipping backwards, and its value is 0.6. And the normal reaction will always be, it is always going to be perpendicular to the surface at the point of contact, and this weight W is making an angle of, we assume it's theta, with the positive y-axis. So this is the FBD, which is to be understood very clearly. And remember, this F equals to 0.6 and comes from this equation, basic equation, F equals to mu s into n. The value of mu is 0.6 multiplied by n. Okay, so this is the initial information that we have gathered from this. So this is, we have assumed that this is our positive x fx axis. Okay, this is our x-axis. So if we resolve these forces along the sigma fx, so we will get this friction component F, which is along the positive x. Then we have basically another component of weight, which is going to be W sine theta. But if you look, W sine theta component is along the negative axis, so it's minus W sine theta equal to 0. But this F is nothing but equals to 0.6 n. So we put it over here as 0.6 n minus W sine theta equal to 0. This becomes the equation 1. Now we have basically apply sigma Fy equal to 0 on this system of ours. So we will see that this normal direction is along the positive y-axis. This is n, and this weight, when it's resolved, this component, which is the w cos theta component, is basically acting towards the negative y-axis. So it becomes n minus w cos theta equal to 0. We can further simplify it that this n is equals to w cos theta. Now, if you put equation number 2 in equation number 1, okay, so you put this equation number 2 value n in equation number 1 over here, you will get 0.6 into w cos theta equals to this minus w sin theta goes on the other side equals to w sin theta. So 0.6 and this w is basically divided with this w. We get sin theta, cos theta is multiplying here, it's divided over here. And we can also say that this sin theta upon cos theta is nothing but equals to tangent theta. So tan theta equals to 0.6. This becomes our equation number 3. Okay. Now the slope of the roof is function y equals to 5 e to the power 0.01x. He has given us over here is that y equals to 5 e to the power 0.01x. So for height h along the y, what we can do is we can differentiate, because we are interested in this value of h. Okay, and we also don't know what is x. So we basically, the only thing that is left is to differentiate it. dy by dx equals to dy dx of 5 e to the power 0.01x. Okay. So now when you differentiate this function, you will say this constant will come out, and this value, basically dy by dx of e to the power 0.01x is written as e to the power 0.01x, dy by dx of this value 0.01 times of x. Okay, so when you differentiate it, this 0.01 again is taken out, is multiplied with this 5, and dy by dx of x is 1. So it becomes 5 into 0.01 e to the power 0.01x. So now dy by dx comes out to be equals to 5 into 0.01 is 0.05 e to the power 0.01x. This is considered as equation number 4. Now you have to be very careful. This dy by dx already know from the mathematics that it is nothing but it is the slope. Okay, and this, what is slope? Slope is defined as the tangent of inclination. So this dy by dx could be replaced as tan theta. But what is the tan theta in equation 3 we have in this system numerical? It is 0.6. So we can say dy by dx equals to tan theta equals to 0.6. Okay, so once this is considered as equation number 5, and now you put equation number 5 in equation number 4. Okay, so you put equation number 5, this equation number 5 in equation number 4. So in place of dy by dx, we can put it as 0.6. So we get 0.6 equals to 0.05 e to the power 0.01x. Now this 0.05 is multiplying, it gets divided over here, equals to e to the power 0.01x. Now when we divide this function 0.6 divided by 0.05, we get 12 equals to e to the power 0.01x. Now we want to, basically this is an exponential function with a power of 0.01x. We can simplify it by taking natural log on both sides. So we say ln of 12 equals to ln of e to the power 0.01x. So once you know this becomes the function's log, you remember our basic concepts of log a to the power b is going to be again b log of a. Okay, but over here it's natural log, so 0.01 times of ln of e. Now you know what is ln of e. It's a mathematical proof that ln of e is always equals to 1. So we are left with 2.485 equals to 0.01x. Now we divide 2.485 by 0.01. We get the value of x equals to 248.5 feet. So at y, we assume that at y equals to h equals to 5 e to the power 0.01x. Because why we take h, if you look from the previous, from the main thing, this is the h we required, which is along the y-axis. Okay, this is the value of x. So we say that y equals to h equals to 5 e to the power 0.01x. So h comes out to be equal to 5 e to the power 0.01. What was the value of x? 248.5. So when we simplify this value with this function 5 e to the power 0.06, the answer that you will get will be h equals to 60 feet. So it was a good problem. I hope belonging to the type 1 case of friction, and I hope you have understood this problem, and thank you very much. Have a good day.